In this lesson, we will discuss integrations and APIs. Integrations and application programming interfaces, or APIs as they are commonly called, are the unsung heroes behind the seamless interconnectivity and enhanced capabilities of today's modern software applications and automation. When it comes to automation and orchestration, integrations and APIs are really the fundamental elements that drive efficiency, innovation, and scalability in modern systems. Before diving into the specifics of each of these, let's take a moment to define both integration and an API. An integration refers to the process of combining different subsystems or components into one comprehensive system to ensure that they all function properly together. An API, or application programming interface, is a set of rules and protocols that are used for building and integrating application software. An API will allow your product or service to talk to another product or service in a controlled environment and using a specific data exchange format. Now, when we talk about an API, it is a library of programming utilities that are used to enable software developers to access functions or features of another application programmatically. APIs are probably the number one thing that we use in our integrations to be able to communicate between different portions of a microservice or service-oriented architecture. By using an API, we can automate the administration, management, and monitoring of various services and cloud-based infrastructures, as well as a lot of other applications. Commonly, our APIs will use either REST or SOAP to communicate. REST, or the representational state transfer, is an architectural style that uses standard HTTP methods and status codes, uniform resource identifiers, and MIME types to achieve a simple way to interact in a stateless manner with a given web service. REST usually relies on using the JSON format when transferring data, which also makes it a very lightweight protocol that can be easily integrated with existing websites without needing to perform any kind of extensive modifications. SOAP, or Simple Object Access Protocol, is a protocol that defines a strict standard with a set structure for the message, usually in XML format, that includes a header and a body that is used to transfer data between two different services. SOAP is known for being more robust than REST by having some additional security features and its ability to provide transaction compliance. This makes it a great choice for any enterprise-level web services where complex transactions and regulatory compliance are essential. While REST is generally more straightforward and adaptable to utilize, SOAP does provide us with a higher level of security and transactional integrity that caters to some different use cases and requirements. Now, when we talk about APIs, we think about these from a perspective of integration. APIs allow for integration between lots of different services, especially cloud-based services. Most cloud-based service providers also allow us to do provisioning, configuration, deep provisioning, and lots of other things to the services by using these APIs. APIs will also allow us to have direct integration of different third-party applications into our own web applications. By using APIs, we can integrate services together and make function calls to those services instead of having to build an entire service ourselves. With the API, we can just call on someone else's function and let their service do the work for us and return the results back to us. This is the whole idea of creating a microservice or service-oriented architecture instead of building a monolithic web application. Now, let me give you a great example of how we use integrations and APIs in our business here at Dion Training. To conduct our student support functions, we use centralized service management system called Freshdesk. Freshdesk is a commercial software as a service product that we pay for every month, and we use this to be able to get all of our trouble tickets or questions submitted by our students, and then we can track those things to make sure that you're getting the answers you requested. So the way we have it configured is that if you email support@diontraining.com, it will get sent to our Freshdesk system so that our team can look at those emails, which we call tickets, and then answer the question that you sent us. You can think about this as like a shared inbox, but since it's actually a ticketing system, we won't lose track of any requests we receive from our students so that we can make sure everyone's questions are being answered promptly. Now, we also provide some of our courses on Udemy, and the Udemy students also want to be able to ask us questions about those courses. But most Udemy students don't email us directly, and instead, they simply post their questions inside the question and answer section of that website. Unfortunately, Udemy Q&A system was never designed to support instructors like Dion Training that have over 1 million Udemy students. So it is really easy for student questions to get missed in the QA section. To overcome this limitation, we would need to be able to rewrite the Udemy website to add the ticketing system capability to our instructor backend of the Udemy system. Since Dion Training doesn't own Udemy and we don't have access or rights to modify their website's code base, we cannot add a ticketing system to the Udemy instructor backend. So, how can I get all of those Q&A posts loaded into my First Desk ticketing system so that we can track and answer all of our students without missing any of those questions? Well, if you guessed that we should use an API, you are correct. Udemy has created an API that allows anyone to programmatically read and respond to any Q&A post. So our development team at Dion Training spent about a week creating a small integration to query the Udemy API. And anytime there's a new Q&A posted, we read it from the Udemy API and then create a new ticket in First Desk using the First Desk API. Now, all of our Udemy Q&As will show up as trouble tickets in our system, just as if the student emailed us at support@diontraining.com. Now, when our team answers the question, instead of sending the response by email, since we don't know the Udemy student's email address, our system runs another automation that will read the response from our First Desk ticket using their API, and then post it as an answer to the Udemy Q&A using the Udemy API. This is the type of integration that you can do using API, and in this case, the entire integration program is less than 150 lines of Python code running in a serverless AWS Lambda environment. The entire thing took us about 1 to 2 weeks to create, test, and deploy, and it only cost us about $1 per month to run this code every 4 hours to get the new Q&As, create the trouble tickets, and post the responses back to the Q&A section once our team answers them. This integration allows our team to work more efficiently since they can answer all student questions in one place inside of First Desk, and then the answers are sent back to the student to their preferred support channel, either email or the Q&A section, depending on where they submitted their question initially. For the student, they will never know anything is happening in the background with this integration, but instead, it looks as if I or Jason logged directly into Udemy and responded to the Q&A that you posted. But for our team, it is easier for us to manage and allows us to help more students quickly. Another example of using an API integration is one that we built that allows our students to access our hands-on cloud-based labs inside of any of our courses that you may have purchased on diontraining.com. So if you take a course at diontraining.com, you will see video lessons, quizzes, our downloadable study guides, and our practice exam, all of which we created ourselves. But when you get to the lab-based section, you will simply click on the link that says Launch the Lab. The lab environment will be returned to you inside of our learning management system using this backend integration. When it comes to the labs, we don't build those ourselves, but instead we rely on a third-party partner that we work with, and we use them to integrate their labs into your course experience. And we want it to be integrated in a way so that you don't even realize that it was a third-party provider tool. In fact, in the old days, we used to not have this integration, and instead our students had to log into the lab provider, the different username and password, and then select the lab that they needed to take at a specific time. By using this API integration, we remove the need for you having to use another username and password, and the need to go to a different website, and the need for you to figure out which lab for the 20 or 30 that are included in the course should be performed at that specific time. But with our integration, the whole experience is optimized. So if you're taking a course at diontraining.com, you will have access to that full lab environment as you're going through the course. You will watch a video and eventually get to the one that says, now here's the lab. In this lab, you're going to do X, Y, and Z. Click this link to start the lab. And that link actually looks something like you would see here on the screen. It says something like diontraining.com, action equals run, instance, and ID equals, and the count and the access key and all those things. These are the parameters that we are passing to the API of our lab provider. This allows our lab partner to know which of our students is taking the lab based on their student ID, which lesson they are at in the course, which lab needs to be ran, and the authorization token. We send all of these details to our lab provider using their API, and in return, they provide us with the lab information and the lab launch link that will be displayed on your screen. This is actually a magic link that will let you open the lab within the next 3 minutes. Once you click on that link, it will load the lab inside of our learning management system for you. You may have also noticed that the URL has an authorization token included in it as well. This is because the cloud provider needs to be able to know who they're servicing because we have hundreds of thousands of students, and by knowing which student you are, they can give you the right services that we already paid for on your behalf so that you're not charged anything additional to access these labs. Now that we understand a little bit more about application programming interfaces and integrations, you may be wondering, how can you test if a given API is working properly in your existing automation? One of my favorite tools to interact with an API is the curl tool. Curl comes installed by default in Linux and macOS systems, but you can also install it yourself on your Windows system. Curl is a tool used to transfer data to and from a server using one of the supported protocols, including HTTP, HTTPS, FTP, FTPS, SCP, SFTP, TFTP, DICT, Telnet, LDAP, or File. Now, all of these protocols can be used with curl, and the one you will use to test the API is usually going to be HTTP or HTTPS, depending on if you're testing an API that is using an insecure connection or a secure connection. So, how do you use curl? As a cybersecurity professional, I can use curl to test an API by using the basic command curl space dash dash data space, the argument that you want to pass, and then the URL of the API. So, for example, if I wanted to test the http bin.org API, I can enter something like curl-data, double quote, first name equals boolean at last name equals world, double quote, https colon / http bin.org/post. In this case, I'm sending the first name equals boolean and the last name equals world, and then I'm sending this to https colon / http bin.org/post. When I'm sending that information, what will I receive back from the API? Well, for the HTTP bin API, we will receive something in a JSON format that has data that includes a list of arguments and fields that came back from that particular API. This allows you to send the data over the API and see what comes back as a response, which is very helpful if you're working as a software developer or cybersecurity software engineer as part of a penetration test. So remember, integrations and APIs are used to seamlessly create interconnections between different services to enhance their default capabilities. Integration refers to the process of combining different subsystems or components into one comprehensive system to ensure that they function properly together. An API, or application programming interface, is a set of rules and protocols that are used for building and integrating application software. An API will allow your product or service to talk to another product or service in a controlled environment and using a specific data exchange format. When we are using automation or orchestration, we rely heavily on the APIs to create an interconnection between our different microservices or services provided by our third-party partners.